if you want to be an expert, you need some qualities. You all are my brothers, and I am your well-wisher and a teacher. Okay. What is my well-wish? My wishes is that you have to become an expert, not an engineer. There are thousands of engineers in all over the globe. Am I right? There are thousands of engineers, but everybody is not an expert. Correct? There are engineers but not experts. Experts are limited. Okay. So here you are joining the classes to become an expert. To become an expert, you need some qualities. That is, first I need patience. Why? If you don't have a patience, you cannot repair a motherboard, because the motherboard doesn't speak. I have to communicate with the motherboard. Very, very important. If I have to communicate with the motherboard, I have to understand what is the problem in a motherboard. For example, a small baby is crying but it can't speak. The mother should understand what's the problem to that baby, so that it can fulfill the needs of the baby. Maybe the baby is hunger, maybe it has a stomach pain, maybe it has a headache, maybe the legs are paining, maybe an ant has bit that baby. Still the baby can't speak. Okay, a 3 months, 6 months baby, it cannot speak. Here the mother has to should have the quality to understand completely what are the requirements, what is the problem with the baby. Same also, we have a motherboard. For that, the motherboard has conflicts, it has problems, but it cannot express what problem it has. It can be a voltage problem, it can be a current problem, it can be a IC problem, it can be a chip problem, it can be semiconductors, it can be conductors, there can be XYZ. Okay. So for that, see, a mother is a God gifted. Okay, she doesn't get trained, she doesn't have a teacher to become a mother, she is a God gifted. But here, to repair a motherboard, we are not God gifted, we have to get trained and open our qualities. What are the qualities? The first quality is patience. Getting my point, brother? The first quality is patience. The second quality is you need some common sense. Why? If you don't have common sense, you will be always running behind some trial and error. Maybe the problem is minor, okay, but you don't have patience and common sense. What happens? You will be doing some other experiment, you will start thinking differently, and you will start doing trial and errors, you will start doing tampering. Maybe the problem is very simple. Getting my point? So for an expert, these all qualities I am speaking about an expert, you need a common sense. Every engineer requires common sense. Okay, and it is a God gifted to every human being. Even a cat has a common sense. Suppose you put salt in the milk, give it to the cat, it will not drink. Put some sugar in the milk and give it to the cat, it will drink. Without sugar also, if you give the milk, it will drink. But if you put some chili, then also the cat will not drink the milk, because it has a common sense to think what it has to do, whether it has to drink the milk, whether it should not drink the milk. If you put salt or any chili powder, it will not understand the taste. Correct? When an animal, because this common sense is a God gifted to every living being, okay, who can breathe and who can think. So if I want to be an expert, I should have a common sense. Okay. Coming to the third point, I have patience. Okay, my mind is complete cool. I have common sense. That means unless and until I don't analyze, realize, I will not finalize. What you have to do? First you have to analyze, second you have to realize, then only you have to finalize. Okay, this comes under common sense. Third, to repair a motherboard, you should know the map. Okay, suppose Anselmi came from Ghana to Bangalore or Chennai, he came to India. Without map, how could have he reached India? Okay, he might have made some study, what he has to go, where he has to go, what he has to do, how to find the map, the address, the contact person, everything. So he made his homework before coming to India. Like that only, we should have a knowledge to read the map to reach our destination. So to reach our destination, we need to read the map. So for this, every engineer mandatorily requires a theory knowledge, which almost engineer avoids. You getting my point? Almost every engineer avoids to gain knowledge. They need some practical shortcuts. If you want to do a practical, see, if you don't know swimming, if you dive in a river, lake or pond, what will happen? You will definitely sink, correct? You will drain. Why? You don't know swimming. So without a theory knowledge, if you want to go for direct practical, then that engine is the biggest fool on this earth. So coming to the point, for an expert, it can be any architecture, it can be mobile, it can be tablet, it can be a mobile laptop, it can be a Mac, it can be Apple, it can be anything. The concept is universal. For a mobile, tablet, laptop, for a Mac, everything is an universal. What if I learn universal knowledge? That means I can repair any architecture. I can learn with a normal laptop, I can learn with an Apple, I can repair a tablet, I can repair a mobile also. Almost the concept will be same. Getting my point? So for this I need theory. You can ask me, sir, what is the benefit of a theory? Brother, suppose I have got a motherboard. Okay, if I have common sense, almost I will repair. I have patience, I am an expert, I deserve to repair this motherboard. If I have a theory, I know where I have to go and what I have to change and what I have to repair. When I know the theory, I will not have any fear on this motherboard. I will not have any fear. Okay, so theory helps me to go to a right direction. After theory, suppose I have a motherboard, okay, and it is not power on or it is not getting any display. So usually we get only two types, either no display or no power, correct? So in this scenario, if I have a theory knowledge, I will know where I have to go, what I have to change, what I have to repair. For that, I should understand the requirements of that section. Like you are going for a church, you will have a different discipline. You are going for a mosque, you have a different discipline uniform. When you are going for a marriage, okay, everybody can gather to a marriage, but there is a different discipline, different uniform there, correct? A different ambience. So we will prepare ourselves according to the situation, correct? Same here also in a motherboard. When I am stuck somewhere here, so I should understand what are the requirements of this section, how it works, when it will work. This all if I understand, it will be very easy for me to repair this section and my laptop will power on and display will come. Getting my point? Very good. So I have got the theory, I have got patience, I have got common sense. Now I need practical perfection. Almost many members has practical, but practical is completely different from practical perfection. Suppose you are doing a conversion, okay, usually you see people that the small resistors are not soldered better, so the conversion is not completed. Suppose you are working on a PWM IC, you are changing a PWM IC, the LEDs are not soldered. What will happen? The IC may not work. Even one leg, even the grounding is not completed also, your IC will not work, the circuit will not complete. So you need a practical perfection on a chip level repairing, as well as fabrication, as well as assembling. Getting my point? So you need to assemble also, you need a practical perfection when you are assembling. So yesterday I got a board, the laptop was working fine, but while fitting the screws it got tampered, the USB IC was short and the whole motherboard got dead. Why? The lack of practical perfection in assembling the motherboard. So you need that practical perfection. You need a practical perfection in replacing the resistor, capacitor, diode, MOSFET, BIOS chip, PWM IC. You need a practical perfection when you are doing a reflow, reball, replace. Everywhere you need a practical perfection. Okay, almost people does practicals, but only an expert does a practical perfection. Getting my point? What is the investment we are going to do on my lab setup? The investment is my theory knowledge. I will not invest any space unless and until it is required. So almost motherboards what I repair, I invest very less components, very rarely. I think Anselmi has also seen. I will teach you different style, okay, how you have to repair. Inshallah, I will send some videos also here only for this group, but you are not going to share anywhere, because this is my family group, this is my pride. Anybody who learns from AFS solution is my family member. I proudly say you all are my brothers, okay, my AFS family brothers. So unless and until there is a requirement, I will not shift any components. Done? Suppose it is burned, damaged, open, value change, then only I will change. So investment is only theory. So suppose if I invest for the theory, I will charge $1000 as per Indian currency to my customer. How much? $1000. Still I have not invested any spares, and spares will be extra, and this will be paid by the customer. Here also I am not doing any investment. The investment of the spares is given by the customer along with my experience, theory knowledge. So it will be 1000 rupees plus spares cost as per Indian currency. Okay, Ghana, I don't know how much it will be, okay, or Nigerian, I don't know how much it will be, but here the space is given by the customer. Next, God has given us 2 ears, 1 mouth. What is he trying to tell? He is trying to tell us that we have to be a good listener and speak less. Why? A good listener is a quality of an expert. He will understand what I am trying to teach. He will understand what is the problem with the motherboard, and unnecessary talk is always a waste, like I had spoken yesterday. Okay, unnecessary talk will definitely be a waste. Getting my point? So we have to be a good listener. Hope you all promise me to be a good listener. Okay. Second, the next part is, for an expert engineer, I need some good quality of tools. Like I need a good multimeter, a good DC power supply, I need a good SMD blower, I need a good flux, I need a good lead, I need a good tweezer, a good screwdriver. I need all quality tools. So I will write the word quality. I don't need quantity. Quality tools, and I need a pair. That means two set. Always I need two sets for a backup, but oscilloscope and some SMD blowers you can keep it an optional, because it bears little bit costly. And coming to the BIOS also, programmers, you need two programmers and two multimeters, two DC power supplies, if you can bear the cost. Whichever the machinery is little bit costly, you can keep it only one number, but any cheaper gadgets you need to keep a double. That means you need two. Okay, two set, or I can keep two. So I am matching the drawing along with the inductors and with this. Edit tool, commenting, favorite, yeah. Now yesterday we saw that this is CN12, CN12. So this is also CN12. Okay. This white color mark is my pin number 1. You can see this white color mark. This is pin number identification. How to start? So here this is my pin number 1. This point. So this is 1. This is 2. This is 3, and this is 4. So this part is related to this one. Okay, this is nothing but this one. In these 1 and 2 are input voltage, 3 and 4 are related to ground. Same vice versa, 5 adapter ID. So this is related to 5. That means opposite to 1 is 5. So opposite to 1 is 5, means this is 5, 6, 7, 8. Okay, opposite to 1 it is 5. So 5 you will have adapter ID, 6 it goes my ground, 7 LED 1. What was LED 1? LED 1 was for adapter confirmation, adapter present. 8 LED2 means battery present plus charging. So in this we have completed this part. So in this we have completed the pin details. This supply is passing one capacitor and going to an inductor. You can see here two inductors. Let me show you. This is inductor 1 and inductor 2. So this is coil PL16, PL17. You can see here PL16 and PL17. So these are my inductors. After passing this inductor, this is going to PQ27. PQ27 means you can see a dot. If this is a dot, this is pin number 1. Okay, if this is pin number 1. If this is pin number 1, these 3 points are source, this is gate, and these 4 points are my drain. So the coil is connected to my drain. So let me see here whether the coil is connected to drain. Yes. So the inductor output is connected to my drain. The output is source. Okay. So when I get a message or without a message, this is my output. Source is my output. So here source is my output. Up till here clear about this box? Everybody clear?
Yes, sir.
Very good. I know you all know these basics, but still this is a part. Okay. Now we'll start from here. So inductor, I have told you different functions. Okay. When I am speaking about inductor, inductor is represented with the letter L. It is measured in Henry. Okay, it is measured in Henry. Symbol same like a coil. Okay. Same like a coil. Function it blocks AC pass DC when it is related to voltage. But there is one more function. It purifies DC and purifies AC signal. Not voltage, I am speaking about signal, analog or digital signals. Okay, A or D, analog digital. So this is my basic about inductor. So When I am speaking about a component, so this comes under conductor. Okay, conductor means without any permission. So this has no polarity. So you can put in any direction. This doesn't require any polarity. Okay, so when you are going for an advanced engineering, when you are going for an advanced repair, there are some basic important things to understand. Okay, never guess. Okay, never guess a component with shape, size or color. Okay, never guess a component with shape, size and color. Why? Because the board is getting compact. The board is getting compact. The board is getting advanced. The more it is getting compact, the components are getting compressed to save the space in the motherboard. Okay, on this basis, a capacitor also can look like a inductor, a resistor also can look like an inductor, and even I cannot subject as a space also. It can be size also, size, shape or color. It can be smaller size, it can be a bigger size. If it is a bigger size, it is easy for me. If it is a smaller size, it is difficult for me. So how to confirm what component it is? Okay, the first subject is with the represent of letter. Okay, represent of letter. Letter. So when I am speaking about inductor, the letter is represent with the letter L. So this is important to me. Okay, so wherever, whenever I see a letter with L, I am short sure that this is an inductor. Okay, so if I come to schematics, so I have one more option, that is schematics. When I come to schematics, it will be a symbol, and the symbol will be represent with the letter L or PL. PL means power inductor. So here the L itself is an inductor, but sometimes there will be PL. Okay, it can be a power inductor. L means inductor. So this is represent or when I see in schematics. Okay, this is related to schematics, this is related to board print. Clear? Like when I go for a motherboard, when I am speaking about an inductor, as we saw, even this is an inductor, even this is also an inductor. Correct? The inductor shape can be in a smaller size, it can be a bigger size, it can come in this size also sometimes. Okay, it can come in this size also. So what it is trying to tell me, I should never guess a component with shape, size and color. Okay, let me see if any other inductor is present. Here I don't think so. I am not getting any inductors here. Yeah, why I am pushing about inductors, I will tell you. Okay, one sec. Yeah, the inductor can come in this smaller size also. Beware, that can come in this smaller size. Like you can see two inductors here. Even this can be, see, L33, L32. These both are inductors. See, when I zoom out, that is a very small component. When I zoom in, it is really visible to me. Okay, I will tell you why I am going for an inductor. Hope about the inductor you are correct, clear. The reason why I am going through an inductor is, we have understood about the function. Okay, but for a chip level engineer, inductor is a very important point. Why? Because this is an important testing point for me. Always inductors are clue points for me. Always inductors are filtration points for me. Testing points, multimeter, clue points, voltage, filtration, DSO. I mean to say, when I am working on a motherboard, okay, when I am working on a motherboard, when I am checking on a DSO, I need purification and filtration. Inductor is a very important point. Okay, why? Whenever I am injecting a voltage, okay, whenever I am injecting a voltage to an IC, I need a pure voltage to go inside. So what I will do, before putting a voltage, I will put an inductor. Like if it is a VIN voltage, even it is a desktop, even it is an IO controller, before giving a voltage, I will put a inductor. Remember, brother, to purify the voltage. So inductor is a testing point to me. In future also, there are many sections where inductor is a testing point. Example, a PCH. You cannot remove a PCH, or a graphic chip. You cannot remove a graphic chip. Okay, you can remove a processor, you can remove a RAM, but PCH and graphic chip you cannot remove. So at that scenario, you can see small inductors present there, and these inductors are the testing points for the voltage. Getting my point? So for a PCH and a graphic chip, these inductors are testing point. Now, power on no display. In this scenario, you have or hard disk not detecting. You can go for inductors, USB not working, camera not working, display, hard disk. All this scenario, you can go for inductors where you need a filtration. Sometimes there will be dual inductor, sometimes there will be a single inductor. Okay, so this is also a very important testing point for us. Getting my point, brothers? Anyway, so inductor is clear.
Yes, sir.
So Getting my point what I am trying to teach you, brothers?
Yes, sir.
Yeah. Hope you all are trying to understand. Okay. Good. Now we will come back to schematics. So in schematics, this part is clear, this part is clear. This is a MOSFET. Before going to MOSFET, I have to understand few things, like I have to understand diode, I have to understand transistor, I have to understand JFET. Okay, I have to understand three things. Okay, let me clear this also. What is a MOSFET? When they started inventing a semiconductor, I spoke to you about conductor. Now we have something called as semiconductor. So all the electronics is divided into two parts: conductor, semiconductor, and third is our insulator. That means non-conductor of current is called an insulator. In semiconductor, we have a diode. Diode means it is an anode and cathode. We have one more diode that is called as Zener. It is an anode and cathode. So this is my diode. I am telling just basics. I am not going to the depth. Okay. In diode, what is the function? First, it is represented with the letter D or PD, power diode. Okay, this is symbol. Next, function. First, it can do a forward bias. That means when I give voltage at anode, the output will be at cathode. Okay, that means I have to give a voltage like this in this direction. The output will be in this direction. If I give reverse voltage, it will not work. Okay, so it works in a forward bias. The second function means I can write a small drawing here. I have a voltage path, I have a ground path, suppose I have a diode here. So this is a forward bias. Why? The voltage is connected to anode and the output is my cathode. It is very important. Okay, you may underestimate these components. I am telling you, these components is not as simple as a human being thinks, because this is the basic of an electronics. If your basic is strong, your repairing will be strong. And if a circuit requires an diode, that means it is not a fool. The engineer who has invented a motherboard, the architecture, if he has put a diode, that means he is not a fool. Who is a fool? Who underestimate this tracing. He is a fool. Okay, so if I want to be an expert, I should not underestimate this component. I can use multimeter also, I can use DS also. Okay. Now second point, we can use this diode as a protection also. For example, if I put a diode like this, here anode is connected to ground, cathode is connected to supply. This is a positive point, this is a negative point. Here it is working as protection. You will find these conflicts. Example, in my DC jack, my Vin is coming till the jack, but this is not coming outside of first MOSFET. In my DC supply, it will show me 19 volts and 0 amps. It is a clue to me. 19 volts, 0 amps, it is trying to tell me that when I have connected a DC power supply to my motherboard, it is showing me still 19 volts, 0 amps. That means my protection diode is faulty. It is protecting my motherboard. Vin is first MOSFET not switching. Okay, so अरे यार first MOSFET not switching, DC jack. So in my architecture, always I need some diodes which require these types of protection. Hope this is a diode for me. Let me check in schematics. Yes, you can see here PD8. So this symbol represents me that it is a Zener diode. This point is my anode, this point is my cathode. Anode is connected to ground, cathode is connected to supply. Okay. Now you can tell me what is the function of this PD8 in this motherboard. Yes, Emmanuel.
Protection.
Very good. Here the diode is present in the motherboard to protect my Vin voltage. Remember, to protect my Vin voltage. So instead of tampering the whole motherboard, instead of destroying the future circuit, this diode is standing as a soldier to protect the circuit. It will destroy itself and avoid the voltage to go inside the motherboard. Okay, clear? Good, we'll go forward. But in some architecture, Zener diode, okay, I have told you two types of diodes. There is one more called as Zener diode. When a voltage is connected in Zener diode, when I am connecting a voltage, the output also will be voltage. Okay, why? It is I am giving a positive at anode and the cathode is my output. Let me reverse the circuit. Okay, like I will put a circuit like this. In this circuit, what happens if I give a voltage here? Okay, positive, this is cathode, this is anode. So what happens here? Because it is Zener diode, this Zener diode will work on 5 volts architecture. So the drive voltage for this Zener diode is 5 volts. Suppose I am giving 20 volts here. Okay, so this Zener diode will consume 5 volts to drive the voltage and it will give an output of 15 volts. In sum, the circuit it will be written as 5.4 volts. That means the Zener diode will consume 5.4 volts. Suppose I have an input voltage of 19 volts. Okay, so what is my output? 13.6 volts. Clear? I tell you, this is very important. This point about Zener diode, you understood?
Yes, sir. Yes, sir.
Yeah, I think Anselmi already you know about this because Kevin has taught you, even I might have taught you. But the point I am telling you about diode requirements, it is very important. Why? In the beginning, they invented a diode. The diodes were upgraded to transistor. The transistors were upgraded to JFET. It can be a bipolar, it can be a junction, whatever it is. They were converted into a FET. After FETs, it was converted to metal oxide, that is MOSFET. After MOSFET, it was converted to a super IC, that means a normal IC. After an IC, it was converted to a super IC, that means integrated circuit. So they converted to a super integrated circuit. After that, they converted into a chip, that is, it can be a BGA chip like PCH, South Bridge, North Bridge. After that, they converted into a processor. It can be a CPU, it can be a GPU. So who is the beginning? The diode is the beginning. Okay, what is a diode? Diode is a semiconductor. Means when I give voltage, it will work. If I don't give voltage, it will not work. That means it works as a conductor also, it works as an insulator also, it works as a conductor also. So insulator means avoiding voltage, conductor means passing voltage. What is a semiconductor? Only when I give voltage, it will start working as a conductor. If I don't give voltage, it will work as an insulator. So diodes basic is very important. Okay, I will show you what I have taught you. I will show you in motherboards what is the important requirements, what is the important function, what important role these diodes will work. So these diodes will give you many magics in motherboard. Clear? Will work. So these diodes will give you many magics in motherboard. Clear? When it is like a foundation to a building. If my foundation is strong, that means the construction of the building is strong. As an engineer, if my basic component testing is strong, that means for an expert I will be very strong. Okay, how to test a diode? Always keep the diode multimeter in diode mode. Okay, always keep the multimeter in diode mode. You can see a reading also like this. This is board. Okay, this is component. So when I am checking, this is my black probe, this is my red probe. So this is the testing. Keep the multimeter in diode mode. Keep black probe at cathode, red probe at anode, it will show value. Reverse the probe, no value. Okay, if you reverse the probe, no value. Okay, this is testing. In the whole motherboard, usually what we do, we will be checking values of the inductor. Actually, we are testing the values of this diode. So every coil has a value, every section has a value, every diode has a value. That means this diode works as an important part to me. Every MOSFET has a value. So wherever I am seeing impedance, or value of the section or capacitor, it is nothing but I am checking the value of the diode. So how do I check? Black probe at cathode, red probe at the testing point, or I can say black at ground, red probe at testing point. Now clear? Why do we check? Coil value, section, okay. So I think now it is clear. So in this, usually we check the coil values, usually we check the inductor testing points, usually we check the MOSFETs, and we check the core sections also, we check MOSFETs, we check BIOS also. Actually we are checking the value of my diode. Okay, that means I am checking the ohms value. When I am speaking about ohms, that means it's again it will represent as resistor. So I am checking the resistance of the diode.